Hello, my name is Mr. Patel. Today I am going to present on topic non-volatile memory systems in computer systems. Contents are definition, volatile versus non-volatile memory, types of non-volatile memory, characteristics, applications, limitations, future of non-volatile memory, comparison of NVM with other storage solutions, security concerns, and at last, conclusion. Definition. Type of memory which retains its data even after power loss is known as non-volatile memory. Its examples are flash memory, magnetic devices, optical devices, USBs, etc. While volatile memory example is RAM, which which has which cannot which loses its data when the power is lost. NVM is crucial for long-term storage and is commonly used in a variety of devices like computer, smartphones, even in embedded systems also. Volatile memory is a type of memory which requires continuous supply of power to maintain the information stored in it. Even when the power is turned off, the data stored just before the power off will not be accessed again. It will be completely lost. This type of characteristic makes volatile memory suitable for temporary storage devices. Differences of volatile versus non-volatile memory. Definition for non-volatile memory. It loses its data when the power is off. It retains its data even after the power loss. Data retention is temporary, data retention is permanent. Generally, faster, suitable for quick read-write operations, typically slower than volatile memory, though some types like SSDs are faster. Its examples are types or examples RAM, dynamic static RAM, dynamic random access memory, and static RAM. Cache memory, examples of non-volatile memory, flash memory, that is NAND and NOR, ROM, PROM, programmable and read-only memory, electrically programmable read-only memory, electrically erasable programmable read-only memory. Magnetic storages, HDDs, magnetic tapes, optical devices like CDs, DVDs, etc. Use cases. It is volatile memory is used only in where data needs to be temporary. It is needed now, but it cannot be further needed. Then volatile memory can be used. For long-term storage of data, non-volatile memory is crucial. We must use non-volatile memory. Talking about cost, typically cheaper per byte than non-volatile memory. Generally, non-volatile memory are expensive per bit compared to volatile memory power consumption. As volatile memory requires constant power supply, so its power consumption is high. And in comparison to volatile memory, non-volatile memory uses less power consumption. Applications are it is used in computers, smartphones, and tablets for faster access. It is used in data storages, embedded systems, and devices where data retention is crucial. Durability, limited endurance due to continuous use and data writing, varies by type. Some non-volatile memories have a limited number of write cycles, while others can last for years. Types of non-volatile memory. Read-only memory, a type of memory where data is permanently written during the time of manufacturing. It is used to store firmware or system boot up instructions that rarely can change. For example, BIOS, basic input output system in PCs. Flash memory, it is a type of non-volatile memory which is both capable of being electrically erased and reprogrammed. Flash memory is found in USB, solid state drives, SSDs, and memory cards. For example, NAND flash and NOR flash. NAND and NOR both are the types of flash memory, but they differ in terms of data storages where NAND flash has higher data storage than NOR flash. In terms of cost wise, NAND flash is more expensive per bit than NOR flash. Power consumption is higher in NOR flash than NAND flash, and data access is faster in NOR flash than NAND flash. Magnetic storage, it is a type of device which uses magnetic media to store data in it. For example, hard drives, hard disks, magnetic tapes, etc. EEPROM, electrically erasable programmable read-only memory. It is similar to flash memory, but it can be erased and rewritten at the bit level rather than the block level. Generally, flash memory, work of flash memory done on its block level, but in EEPROM, erased and rewritten work is done at the byte level. It's used in devices where small amount of data needs to be updated frequently, like firmware, systems, etc. For example, BIOS settings. Optical storages, optical media like CDs, DVDs, blur ray disc. Examples of it are which uses laser to read and write data in it. It is called as optical storage. Ferroelectric RAM, FERAM. It is a type of memory that uses ferroelectric layer to store data in it. It offers fast read and write access and good endurance, but typically has lower storage as compared to flash memory. Applications are smart cards, RFID systems. Magnetoresistive RAM. It is relative. It is the type of NVM which uses magnetic states to store data. It is not same as optical. It is not same as magnetic RAM, which uses magnetic media to store in it. It is different from that. It combines the speed of RAM with the persistence of non-volatile memory. Its application is in medical devices and automotive systems. Phase change memory (PCM). It is a type of non-volatile memory that changes the state of the materials from amorphous to crystalline. In this case, amorphous is the unorganized data structure, which then converts into the crystalline, that is, organized data structure to store data accurately. PCM offers potentially faster and more reliable data storage than traditional flash memories. Talking about its characteristics, data retention, as non-volatile memory does not dependent on power supply. Even after power loss, it retains its data. So the main characteristic or the key characteristic is data retention for non-volatile memory. Durability. NVM can endure numerous read-write cycles, though some types like flash memories have a limited number of program or erase cycles. Access speed. NVM has lower write speed as compared to volatile memory, that is DRAM, but has faster access speed than the traditional mechanical hard drive. Power efficiency, as it is not dependent on power supply, so its power consumption is very effective for long-term storages. Applications, storage devices like USBs, SSDs, and memory cards all rely on flash memory to store data persistently. Firmware systems like ROM and EEPROM is used to store firmware that boots system or restores or operates embedded devices. Embedded systems, many embedded systems uses non-volatile memory to store operating system code, configuration data, or logs. Consumer electronics, devices like smartphones, cameras, tablets, computers, etc. uses non-volatile memory to store users' data, operating systems, apps, etc. Limitations are write endurance. Some type of NVM, especially flash memory, have limited number of write and erase cycle, which can lead to wear over time. In this, write and erase cycles are limited. That means we can write in it for some particular number of times. After that, we are not going to write in it. Slower write speeds. While read speeds are can be fast, but write speeds are slower as compared to volatile memory. Higher cost NVM technologies, particularly SSDs and certain advanced NVM like 3D NAND, are more expensive per gigabyte compared to traditional magnetic storages. Data corruption risk over the period of time in high temperatures or frequent write cycles. Data stored in NVM may become corrupt or lose its integrity. complexity, the managing and organizing of this data in NVM can be more complex compared to the simpler storage solutions. Limited availability of some types, advanced technologies of NVM like MRAM or RERAM, that is resistive random access memory, may not be widely available as they are very much cost effective for all applications. They are very much expensive, so they are not used that much in it. Future of non-volatile memory. Emerging technologies like 3D exploit and resistive RAM are designed to combine the speed of RAM with the non-volatile of flash, potentially revolutionizing storage with faster, more durable, and higher density memory solutions. That means 3D exploit and combination with resistive RAM can design more faster, more durable, uh, can have large storage spaces. This will make the best non-volatile memory ever. 3D Xpoint is non-volatile memory and storage technology developed by Intel and Micron Technology. It is designed to fill the gap between dynamic RAM, DRAM, and NAND flash. So, become it is faster, denser, and more durable than either. Storage density 10 times denser than conventional memory. Endurance up to 1000 times greater than NAND flash. Speed 1000 times faster than NAND flash. So combining this 3D exponent and resistive RAM, the volatile memory form is very much helpful with its very much key features. So it is definitely very much popular in the future also. Going to be popular in future. Comparison of NVM with other storage solutions. NVM with hard disk drives, HDD, retains data without power, non-volatile magnetic storage. It has own magnetic storage. Data retention both does not depend on power supply, so data is persistent even after power loss. Speed is faster in non-volatile memory and slower read-write cycle speeds due to mechanical components. Access type random access with low latency, random access but higher latency than NVM. Use cases are suitable for higher performance applications, used for bulk data storage, backups, and archival purposes. Endurance, limited write cycles, especially for flash-based NVM, mechanical wear and tear over time, but can last for years. According to cost, generally non-volatile memory are very expensive per gigabyte than HDDs, and as compared to non-volatile memory, hard disk drives are less expensive. Physical size compact and lightweight, bulkier due to mechanical component. Non-volatile memory with cloud storage. Definition retains data without power. Remote storage access solution via the internet. Data is persistent. It retains after the power loss. Data is persistent, but it relies on internet infrastructure or providers infrastructure. Speed, fast read and write speeds depending on type. Speed varies due to the internet connection. Access type, direct access to data. Accessed over the internet, potentially slower than local storage. Use cases, higher performance applications, data backup, collaboration, and sharing across devices. Endurance, limited write cycles, dependent on cloud providers, infrastructure, and redundancy. Storage. Cost, generally higher upfront cost for physical hardware. Subscription-based pricing, often cheaper for large amount of data over time. Cloud storage, that means it offers some amount of storage, so it needs some subscription. After the subscription gets old, we need to refill or purchase new. Power consumption, lower power consumption. Power consumption is high in terms of in cloud storages. Security concerns in non-volatile memory, data theft and unauthorized access. This, as NVM is not power supply dependent, so even after power loss, it can store data in it. So it might possible it may sometimes store very sensitive data after the power loss, which makes it susceptible to unauthorized access if physical security measures are not in place. Mitigation. Implementing encryption for data stored in NVM ensures that even if physical access is gained, but the data remains the protected. Conclusion. In summary, non-volatile memory is essential for retaining data without power and is foundational for various computing devices and systems. It uses spans from basic firmware storage to advanced high-speed SSDs in enterprise environments. Hence, NVM has very much key features, very benefits of it. Hence, it has least disadvantages of it. But surely, the future of non-volatile memory is. Thank you.